thank you very much to Matt. It's going to be a very, I suppose as they say in Monty Python, now for something completely different. I'm a developmental and comparative psychologist. They say never work with children or animals. I do both. I find it incredibly rewarding, but it does mean that I've subtitled my talk or the story of a developmental psychologist who needs two pairs of hands, two heads, and be two places at once. And you'll see why that is the case in terms of some of the approaches and the methods that I use later on. So the question that I'm asking, my thing is not working. Okay, the question that I'm asking within my particular field of research is we get born into different cultures, we get born into social worlds, and from a developmental psychological perspective, what I'm interested in how children become social beings within this world, how they learn the traditions that they have within the society into which they're born. Who do they learn this from? What are the mechanisms around which they adopt this type of behaviour? But I'm also interested in bigger questions than this around what is the importance of culture when we to our lives. Is there something more to it than simply just being a member of a particular group? We're faced with life's problems on a day-to-day basis. We have to work out how we can find food, we have to work out how tools work, and when they don't work, we have to find out and work out how we can fix them. We have to navigate the physical space in which we live, and we also, when we become ill, we need to work out how we can make ourselves better. And societies and cultures provide us with a lot of the information around which we can do these things. We've created symbols and languages. We have complex social structures that allow us to acquire food and also to acquire medicine as well. Now, it could be argued that a lot of we're able to navigate these very complex problems because we're incredibly clever individuals, we're incredibly clever species. But there's more to it than that. Our culture allows us to be able to solve these particular problems. And an example of this comes from the experiences of lost explorers. So you have John Franklin and Robert Burke here. John Franklin set off on an expedition into the Arctic. Robert Burke set off on an expedition in the outback. Now, both of them were exceptionally intelligent individuals, incredibly well-resourced, with a lot of experience behind them. And they were going to locations where there were indigenous populations who were already living there. But both of them ended up with incredibly devastating expeditions, with almost all, if not all, of their party dying. And the reason why was that they weren't drawing on the local knowledge of these indigenous populations. They weren't using the tools that were created in these particular locations. They weren't eating the food that these people did. They weren't drawing on the cultural knowledge that we learn day to day as soon as we are born, that we are exposed to and are able to pick up. Culture also allows us to do something more than simply survive and to just simply function. It allows us to be able to build up our knowledge within the culture which we're working with it. This is something that we call cultural evolution. So we are inhabiting all areas across the globe. We are able to live in the most extreme circumstances, and we're even being able to explore space with the idea that maybe we may end up living out there and have communities living out there. We have really advanced technologies that are always growing smaller, or such as mobile phones, but also more efficient. Their functioning becomes greater. We can build elaborate buildings such as Durham Cathedral, and we can create technologies that initially are physical, that we initially hold in a hand, but through our cleverness, we can make them virtual. So if we set somebody down, I doubt very, very many people would be able to design and create a modern computer from scratch, just from wires and various other kinds of different components. But what we can do as a species and as a community is we can take our knowledge and we can build on that knowledge. And we call this standing on the shoulders of giants. We can take what we've known already and we can add to this. It may be incremental, but those small incremental discoveries and changes mean that we are being able to improve what we do. So why am I interested in children in terms of these really big, grand problems? Well, the thing is, life's problems start early. Children are learning how to use tools, whether they are technological tools or simply learning to tie their shoelaces. But they're also learning to engage and integrate themselves into the very complex social mechanisms in which we work and in which we live. That we have a number of social norms that we mustn't deviate from in order to be able to be accepted into the group that we are in. So much of what we have within a culture is opaque. We wear ties, we use a knife and fork as opposed to chopsticks, we drive on the left. If you think about your mobile phone or any form of technology and we look at it, it's very difficult for us to actually understand how something, unless we're a computer scientist or computational engineer, how something actually is built and how it works and how the components fit together. So because so much of what we do and so many of the social rules that we follow, they have a great deal of opacity. So one of the questions that I'm interested in, how do children deal with this opacity? So this is work that was initially began to be addressed by two of my colleagues and collaborators, Vicky Horner and Andy Whiteman. And the way that we look and we test the children to try to evaluate these questions is by using artificial fruits. And this is an example of an artificial fruit. So we have a box here, and it's opaque, so you can't see how it works, and it's transparent over here. And there is a reward in this inner tube here. Now it's really simple. If you want to get the reward out, all you have to do is get a stick. There's a door here. It can be lifted or slid to the left and right. And you can open that door, stick the stick in the tube, and then take out the reward. But what we do is we present, or what Vicky and Andy did was they presented demonstrations to either chimpanzees or 3-year-old children where they included a number of irrelevant actions, where they removed these bolts at the top of the box and they tapped 3 times into this particular hole at the top. They didn't need to do this, they were completely irrelevant, but then they went and inserted the rod into this particular tube to then get the reward. And what they found when they looked across their chimpanzee sample, which is over here, or their 3-year-old children's sample, they found that when they were looking at how many of them were copying the irrelevant actions, it didn't matter for the 3-year-old children whether they were working on the transparent box or the opaque box. They copied everything across, whether they received the opaque box first or the transparent box first, it didn't matter. They just copied all of the irrelevant actions as well as the relevant actions. For chimpanzees, it was a different story. They rarely copied these irrelevant actions, and it was only when they received this box first of all that they copied those particular actions. So this was quite an interesting discovery. It's really counter to, being a clever individual. Why are you doing these redundant actions? Well, we asked this question along with Nicola McGuigan, again with Vicky and Andy, and we said, well, maybe it has something to do with 3-year-olds, that they don't have the cognitive skills to parse out these irrelevant actions. Maybe there's something that they haven't quite got to that developmental stage yet. And so we got a larger group of children and we tested 3-year-olds and 5-year-olds, and what we found was, for the 5-year-olds, again, didn't matter which task they got, whether they got the clear task or the opaque task. We tested them in a live condition and in a video condition. They copied everything, all of the irrelevant actions. When it came to the 3-year-olds, again, when they're in the live condition, it didn't matter. There was a high level of copying. When they were seeing it on video, they didn't copy these, but rather than us inferring that this is because they are cleverer than 5-year-olds or they are cleverer when they see videos than when they see something live, we think there's a problem in translating a 2D demonstration to the 3D live condition where they had to work it out. So there's something very interesting that's happening. You're seeing these opaque behaviours and these irrelevant behaviours, and you are copying them. This was such an interesting result. It went off to many different labs all the way around the world to see how robust it was, and it's been replicated using many different tasks by many different people under many different conditions. And some of the interesting conditions I just want to highlight If you make the irrelevant actions seem more intentional by adding there as opposed to whoops, unsurprisingly, children are more likely to copy them. If the irrelevant actions are presented by an adult, they are more likely to copy them than if they are presented by a child. If the model or the experimenter or the demonstrator who presented these irrelevant actions stays in the room, they are more likely to be replicated than if the model actually leaves the room during the child's attempt at the task. So these are all kind of indicators of some form of potentially about social pressure. But we also find that children are willing to copy these relevant actions even when they're in competition with somebody else, and there is a reward that they will lose out from if they do continue to copy this, because they're taking longer to get to the final stage. And equally, this is a condition that Derek Lyons, I think, has shown how robust this effect is. He did a number of overimitation studies, tasks with these children. He then says, okay, now we've finished, and he starts walking with the child down the corridor towards the exit to see their mum and dad. He then says as he's walking down the corridor, oh, I can't remember if we put the thing in the box at the end, can you go and check for me? So the child runs back, the camera is still rolling, even when he is not there and there is nobody there, so even under these particular conditions, children are also over-imitating as well. So even though we see it's less common when the experimenter is absent, we're still seeing over-imitation when they think this experiment is over. So we said, oh, children, they are funny, aren't they? Maybe it's just something that they do and they grow out of. So what we did was we went to go and see adults to see whether or not we see this replication of irrelevant actions with adults. And we tested the children's teachers rather than the children themselves. We found that across the transparent and the opaque box, 98 or 100% of adult teachers also copied these relevant actions. When we were out of the room and the camera was still running, 88% of them copied these irrelevant actions. When we said, this was undergraduate students, there's £20 reward for the person who gets the thing out of the box the quickest, 78 of them were still, they just did it really, really, really quickly, but just not quick enough. And also, when we had a condition in which we had a confederate who was pretending to be a fellow participant and had attempted the task first and presented all of the irrelevant actions as part of their turn, although it reduces to half, we're still seeing 44% of individuals, adults this is, copying these irrelevant actions, even though they think this individual is a fellow participant. They don't have any special knowledge about the task, it's just something that they then are picking up and copying. So what I'm trying to look at is the idea that how do other people's behaviours influence what we then do? Well, what we're finding is that children and adults appear to adopt the opaque, irrelevant behaviours of others very easily, even when these have a cost to them in copying. There may well be social motivations to affiliate with a model because it seems to depend on whether or not somebody is present or not, and cultural motivations to act appropriately in a new social context. So if you're not quite sure what's going on, maybe the best thing to do is to copy. Now, it could be argued that it may be a mechanical motivation in that you're not sure how this thing works, so the best thing to do is to copy. But when we're presenting children with these tasks without a demonstration, they understand how the tasks work. They're not doing relevant actions. They're not exploring the boxes. They know exactly what they need to do. But it's only when they've been presented with these opaque, irrelevant actions that they are copying something else. So then we asked ourselves, well, what if you actually do something that is really explicitly wrong? Not morally wrong, I should say. We don't get to the moral issues of this talk until the very end, but just functionally wrong. Will you still copy something that you see somebody else do if what they're doing is really ineffective? Now, we presented this puzzle box to children, and you'll see with this box it has many different holes. These holes can be used as entrances and exits. There are 3 different tools. Some of these tools can be combined. You can just see here a reflection of a very long tool which goes across the box. So there are many ways of getting an object in and out of this particular box. And what we did was we inserted a Kinder egg, we used Kinder eggs with stickers inside as a reward, and we presented 4-year-old to 9-year-old children and some adults with a demonstration, 8 demonstrations, where a demonstrator repeated exactly the same mechanism of trying to extract this particular object every time. And the way that they tried to extract it was by inserting the hook tool here into this hole, pushing this object into this hole in the top. It then fell down behind this door, but the very clever thing that we did with the door was we had it on a remote control, so we could lock the door or not lock the door as we needed to. And what we were doing was saying, well, okay, if we presented demonstrations versus no demonstrations, but on some occasions they were successful and some occasions they weren't successful, or there was a different ratio, would children copy these particular demonstrations? So we were hypothesizing that if it was never successful, they should be more likely to try something new than if it was always successful. And we also had a rate where it was successful 25% of the time or 75% of the time. And what we're asking is, if you see something that's always incorrect, will you try something new? Or if you see something variable in terms of its success, are you likely to be more likely to innovate based on that variability? What we found was across the conditions was that when it was never successful, we did see significantly more likely for innovation, especially around the exit. So it's the exits that's the key. You don't have to try a new tool, you don't have to try a new entrance, you can if you want to, but it's literally the exit which is the problem, and that's where you need to innovate around. When we're looking at age, we also see increases in age in the likelihood of innovation, with older children being more likely to innovate than the younger children. But the thing that was absolutely outstanding from our results was we had 209 children within these particular conditions, and only 26 of these children attempted an exit innovation at some time. Innovation, when you are presented with a social demonstration, irrespective of how successful it is rare. Even when you're seeing it being unsuccessful a lot of the time, there are a number of children who are still trying to replicate that particular behaviour and not trying to do something new. So when you see somebody doing something, even if it's wrong, you still carry on doing it. You're not trying to do something new. So the thing about culture, and what I've talked about so far, is that I've been talking about dyadic studies, but culture is much bigger than dyads. It's not about a grown-up showing a child what to do. A culture is about all of us learning from one another. So what we need to do is we need to have experimental approaches which allow us to be able to look at culture as a group phenomenon. So we need to consider how we can explore how information or behaviour is transmitted across groups of individuals. Now, one way in which I do this is by using a diffusion chain design, where it's like Chinese whispers, the children's game Chinese whispers, where we take dyadic sequences of children and we either train a child or we have a child who can do a particular behaviour at the very beginning of this chain. And what we're trying to do is see, well, if we have a child being observed by another child, who is then observed by another child, who is then observed within pairs, what happens at the end? So if we see a certain type of behaviour, does it still exist at the end of the chain? And so in this particular study, what we did was we had a puzzle box where they had a stab technique, where it had a fork and a hole in the top, and you opened it up and you could stab this fork to get some rewards that were inside, or it had a slide technique. The thing that's nice about this is it's much freer than an experimental setting. Children are learning from children. We can see the incremental cumulative effect or not of certain types of behaviour, and it's often taking place within the children's real environment. We're not taking them into the lab. This is children learning from their friends, and this is something that they do all the time. So we had 83-year-olds and 85-year-olds, we had chains of females and chains of males, and we had two chains per particular condition. So either that was seeded with a stab, we trained the first child in these chains to use a stab versus a slide. We also had a group of control children who were simply presented with the task without watching any demonstration. I should say that what we have within the study is we train a child up, they then have 2 attempts while the second child in the chain is present. We don't talk about teaching, we don't talk about watching, copying, showing, telling. They are literally just happen to be present while this behaviour is being undertaken. We are not trying to force children to copy it with high fidelity. We just want to see what happens. If you observe this, are you likely to copy it? So what we found was, these are my poke chains, these are my slide chains. The top one is 3-year-old females, 3-year-old males, 5-year-old females, 5-year-old males. It looks a bit complicated, it's not that difficult. So with the pokes, if they're dark, it meant that they were successful in using a poke. If they're hashed over here, or blank, it means that they were attempting that particular method, the poke method, but they weren't successful in extracting a reward. Over here, we have the slide condition, where if it's grey, they were using slide. If it's hashed, it means they attempted to use slide, but they weren't successful in using it. The take-home message that I want you to get from this slide really isn't, it's not that big. This is the only child who attempted something different in this experiment. So everybody else attempted what they had seen seeded within the chain. This child picked up the poke tool, attempted to use the poke tool, wasn't successful with that particular method, and so then returned to the slide. And the thing that's interesting about the slide method was that it never occurred within the no model control condition. So it's not a natural behaviour for any of the children here. They were learning it from those individuals that they were in the room with when they were undertaking it. So out of all of these children, we only see one 3-year-old female who is willing to deviate from what they have seen somebody else do. Things with diffusion chains, they're fantastic because they allow you to control the sequence of children and the property of children within the change, and you can compare boys and girls, and you can compare 3-year-olds and 5-year-olds, or children with a certain type of disorder or not. But really within the real world is so much more complex and confusing than this, and what we have is lots of types of information, lots of types of demonstration, lots of types of models that you're learning from all the time, and this is what we wanted to explore, and we do this using an open diffusion design. And we went into real playgroups where children have networks of friends and networks of affiliations. And we wanted to see, well, okay, if we take a child and we seed them with a certain type of behaviour on a particular task, how does that spread across the group? Do we see high fidelity in that spreading in the group as we do in these diffusion chains and these other dyadic studies, where we're seeing a great deal of copying and very little deviation and variance? And if we are seeing transmission across chains, is it very random, or are people, what's underpinning it? Is it intelligence? Is it affiliations? What are the mechanisms that's allowing it to be translated? Is it observation only, teaching, collaboration? And so we took 3 playgroups. One of them was a control playgroup where we simply presented children with a task to see what they would do on it. And in the other 2, we had we introduced a task that was there for 1 hour every day over 5 days, and children were free to come and go as they wished to. They didn't have to take part if they wanted to. They could come and play with it the whole time if they wanted to, with their peers allow it. We took 1 child from each playgroup and we trained this female up. It was a female popular child. We rated all the children initially. And so we trained one of the children to use the poke technique and one of the children to use the lift technique. And what we wanted to do was we introduced it. We said to all the children, here's a new task, a new game. You can play with it if you like. It's going to be here for this week and nothing more. And then we can look at the spread of information across the group. Who is learning from whom? Whether they're observing the seeded behaviour and a failed attempt at the seeded behaviour, a new behaviour. What we discovered was, we thought there were two techniques with this. The children invented a third, which is really interesting because it makes things much, much more interesting for us. 48 of the 58 children participated, so they were involved. 10 children weren't interested at all. We had 1,322 turns over the 5 or 10 days, 2 times 5 days, and from those 318 successes. So what we concluded from this open diffusion work was that children again were copying those methods that they witnessed, but we did see more deviation and change, more variance. But this wasn't random. What we were having was a group that was initially seeded with Coke actually turned into a T-bar where they invented a new method. Doesn't matter what it was, but they invented a third method, and that was transmitted across the group about halfway through the week. The children that were seeded with Lift turned into a Poke group. And we saw some microcultures within these particular groups of children where they were copying what they had witnessed most often. The forms of transmission most commonly were through observation and a little bit of teaching. And age appeared to be one of the critical features about how this was transmitted. Older children were watched more, they watched others more, and they were more faithful to the seeded methods. We profiled all the children across a number of different mechanisms around, a number of different characteristics such as temperament, their popularity, their friendship, their intelligence, their ability to imitate with high fidelity, their executive functioning, their theory of mind. We found the social factors of the things that were underpinning this particular transmission. Children were learning from their friends, and they were learning from the most popular other children. So finally I get to the issue around, I suppose the work that I've been talking about is relevant to this idea of agency. How much agency do we have when we have been given some forms of social information? But within my work, I've worked an awful lot on kind of learning about technologies, learning about tools. And what I'm more interested in now is learning more of the more abstract concepts and norms that we might have within our society. So I'm working at the moment on looking at cooperation and whether or not this is infectious with children. And this is actually work that I do with Natalia Dutran. She would be here today, but this is Clarice and she's only 6 weeks old, so she couldn't be with us. But this is very much her work, it's her PhD work. And what we were interested in is, along diffusion chains, whether or not, if you seed cooperative pairings, does this get transmitted along the chains? And is this affected by the type of task that children are undertaking? So we looked at 2 different types of tasks. Tasks that were very social tasks, where there was no function, you didn't end up holding anything in your hand at the end, but you had been through a rewarding social experience, or tasks in which there was some kind of function. So for this one, you had to push up a platform here, and another child had to go round to this shelf to get the object or the prize that you were pushing up, and you couldn't get it here while you were pushing it up. Whereas this one here is a social game where you are literally bouncing a block, and there is nothing that you will really hold in your hand at the end. It's just meant to be an enjoyable game. We were also interested in seeing whether or not you would see less cooperation if you are having to coordinate across tasks that require different behaviours as opposed to requiring the same behaviours. So this is a classic dumbbell task. It's a really long tube with handles at the end. You need 2 children to pull it. So they're both doing the same behaviour, and there's a reward trapped inside. So the same actions need to be undertaken. Whereas this one is a double tube task where one child needs to stand at this end and put a block down here with a third child ready to catch it at the bottom. So it's 2 different actions as opposed to coordinated actions. So we wanted to say, well, if we trained up children across these 4 different tasks, will we see the same level of cooperation based on whether or not it's a social task or a functional task, and also whether or not you're requiring a coordinated action versus the same actions being undertaken? And what we found was that it did not matter across chains of children, it did not matter what the characteristics of the tasks were. Children are really good from learning from other children how to coordinate their actions. Even if they're different actions and also even if it's a social rather than a functional task. And this is a comparison to pairs of children where they are simply presented with the task and then they don't have any demonstration to coordinate. This is very much the initial kind of steps in trying to look at tasks for more abstract concepts and behaviours and normative behaviours rather than more functional behaviours. So yes, cooperation among children is infectious. So how does the behaviour of others influence what we do? Well, it does a great deal. When we're uncertain, when we wish to blend in, when we feel social pressure, even when there's a cost to us in terms of time and energy, we tend to copy others. The majority of us, both children and adults, but not chimpanzees, fail to try alternatives when we've been seeded or we see a demonstration around a particular set of contexts or circumstances. Now this may seem like a negative phenomenon, but actually we really do need to have this kind of high-level copying because it allows us to integrate culturally into our society, and also it allows us to not make mistakes that potentially could be in some circumstances fatal. Now we do need innovators for this cumulative culture that I was talking about before, where we are building on the behaviour and knowledge of others. We need new people to do new things. However, this is only going to work if we have stable communities and stable technological developments. We need to have new behaviours and technologies spread so there's a good understanding of how that works before we can start adding things onto them. So from theories of cultural evolution, what we need to have is the majority of individuals conforming or copying to certain types of behaviours, and then rare instances of innovation. And that's what I'm seeing in my open diffusion work. Lots and lots and lots of copying with small elements of innovation over time. Because if we don't see that, then what we have is chaos. If everybody decides to do what they want to do and they have innovation all over the time, then we're not following the social rules and there is no social order because we're all doing what we want whenever we want to do it. So I want to acknowledge my collaborators in this and all the schools, children and adults who have participated, as well as the funders who have funded me for this research. And I want to end by being very non-conformist, and I want to present some questions to you rather than questions to me. It goes back, I suppose, to Catherine's talk, which is when we're seeing such high-level copying against cost to us as individuals, we're copying things that we know are wrong, that we can see are wrong. Does this question how much agency we really have? Why is the influence of others so powerful? How does this differ across culture? And the question and the research that I'm really interested in at the moment is who innovates and under what context do they innovate? And that's it.